Let's now introduce the counter over here. So we are talking about a counter that's bounded, meaning that it has a maximum value, which will be 3, and it also has a minimum value, which will be 0. So the value for this counter can only be 0, 1, 2, 3. If you want to go from 0 down to -1, it should be triggering some exception. If you want to go from 3 to 4, that should also trigger some exception. So that's the conceptual idea you want to have in your mind. And we haven't really reviewed about the static keyword over here, but as far as this lesson is concerned, this is the following you should know, well, at least from the first year. So static simply means the variable does not belong to individual objects. It belongs to the class. So it's more like a global variable that every object of this particular counter class is sharing. But since we make it final in this case, so they never, once initialized, they will never change their value. Okay, so for this module here, you can simply think about static. It's like a global variable. In this case, it will be a global constant because we use final. And the way for you to refer to static variable, you don't really need to use any context objects. You can simply say counter dot maximum value and also counter dot minimum value. You will see that in the code, right? So that's something you should also review. Maybe the notes from your review tutorial video slides, and then also your first year CS notes, engineering notes as well. Okay, let's go on. So we have some private value over here, just integer value, and then we have a counter, and the constructor will simply initialize the value to be the minimum value. Namely, it's going to be 0 to start with. Okay. Of course, at this point, to start with, you should not try to decrement the value from 0 to -1. Otherwise, you will encounter some exception, maybe value too small exception. The counter at the moment is simply too small for you to get decremented. And then we can since the value here is private, we are following our normal practice. All the attributes should be private. So if you want to get retrieve the value for an attributes, you should really declare some public accessor. So that's why we got get value here. And more more to come in a moment. Okay, right. So this point I have already set. Okay, and also about the class-wide. Class-wide simply means global. It's going to be shared by all the instances or all the instantiated objects of counter. And also final means constant. Once it's initialized, it's never going to be changed. And initialize the counter to be lower bound and requirements. So this is really, really important to keep in mind. All our test cases will be designed according to this requirements or principle. The counter value must be between its lower bound 0 and upper bound 3. Okay, keep that in mind. If you want to go out of the bounds, you will run into either value too small or value too large exception. Okay, so there are two possible exceptional scenarios. Actually, I already mentioned them verbally, but let's just take a look quickly. If you try to increment above the counter's upper bound. Let's say if the counter value currently is already 3, which is the maximum value, and you try to increment it further. In that case, of course, you should really get some value too large exception. Symmetrically, if currently the counter is already at its lower bound, let's say 0, and you're still trying to decrement it, in that case, of course, you should get some value too small exception, right? So these are the two exceptional scenarios that we really want to test. So your implementation for the counter should really try to handle either for the normal cases where you can simply increment or decrement the values, and also exceptional cases where you try to either increment above or decrement below the bounds, in which case exceptions will be expected to be thrown. In that case, the tests that we develop should really test to see if the expected exceptions have really been thrown as expected. Right? That's something we'll see. All right, so let's now look at the rest of the methods. Let me just switch to iPad. That'll be easier for me to see. Okay, so this part we have already seen, right? The maximum value, minimum value for the counter. Let's look at these two mutator methods over here. So one is increments. The other one is decrements. And they simply don't take any parameters because we're just assuming that either you will always increment by 1 or decrement by 1. So that's why we don't take any parameter. But as part of their header, you can see we use the specify option. You can see throws, value too large, exception. And also throws, value too small, exception. Right? you can see they are different. So let me say for this one over here, and also this one over here, both of them took the specified options for handling the exception that's originated in these two methods, right? So both of these are the specified option. Okay, let's take a look at the method individually a little bit more carefully. The erroneous exceptions, the erroneous condition that we talk about is like this. In the case of increments, if the value is already equal to the maximum value, in that case, if you try to increment further, well, thinking this way. Think about if this is number line over here. So the minimum value is 0 and the maximum value is 3, right? 0 and 3 over here. So this is the minimum and this is the maximum. And we are saying the following. If the value is already equal to the maximum, right? At this point, if you try to do increments, the result should be the value too large exception. Value too large exception. Otherwise, you can, for example, if I'm here, not really at the maximum value, of course, you can try to increment it by 1 to another value. That's okay. Symmetrically, let's take a look over here. Symmetrically, let's say we got the decrements. For the decrement, let me use a slightly different color. Let's say value would be equal to counter the minimum value, if it is the case. So that means if the current value is already the minimum over here, and then we are trying to decrement, in that case, that should really trigger this value too small exception. Value too small exception, right? Otherwise, if somehow you are not really in the minimum value, of course, if you want to decrement, you will just decrement by 1. So that will be fine, right? So we talk about either this or that. And of course, in both cases, when the erroneous conditions actually are met, you will simply say throw new exception and throw new that particular exception with the error message, which is what we discussed in module number 1. All right, hopefully so far so good. And I want to give you some exercises to think about, okay? And that will be relevant to our design for the test cases later. Okay, let me just put it here. Exercise. I want you to look at the erroneous condition over here, right? One is here, the other one is here. I want you to look at these two. Okay, hypothetically, what if I change them to be, let's say, value smaller than counter dot minimum value. Okay, for this one, okay, let's say for the star. Number 2, what if I say value is strictly larger than counter dot, I think what I meant was maximum over here. Okay, maximum value, and this one also maximum value. Basically, I'm saying for this operator over here, what if I say less than or larger than? Are they going to be correct or not? If they are not correct, how exactly are they not correct? That's something we want to show by our test cases later, but I want you to think about it conceptually. Okay, number 2. So these are the two. And what about the other two exercises? Let's say this is star and also star. Okay, for star and star. I want you to do 2 symmetric exercises as well. So what if I try, rather than equals over here, I might try less than or larger than. So let's say if value is strictly less than counter the minimum value, and also number 2, what if value is strictly larger than counter dot minimum value. Okay, so these are the 4 exercises I want you to think about. You can write down your answer on a piece of paper or type it out on some notes that you usually keep, and then keep those in mind, and that will help you reason about the test design, which I will speak about in the later point in the module. Okay. All right. So that's about what I want to say. Let me see. Okay. So that's about the bounded counter. Okay, let me just go back to the slides to make sure I cover everything. Simple counter over here, and then, yeah, so I talk about when, under what kind of erroneous conditions we'll actually throw the exception. But you want to really think about these four alternative solution. Would it work or would it not work? One more thing I want to say. You can see because maximum value and minimum value, they are simply static, right? They are simply static. The fact that they're static, meaning that no need to access them using a context objects. You don't really have to use the new keyword to create an object before you can say, for example, AC, let's say counter C dot maximum value. You don't have to. Instead, you can simply say counter the class name and then dot, either maximum value or minimum value. I'll just put one example. That's something you have already seen in the implementation. Counter that maximum value and counter that minimum value, right? All right, that's something syntactically I want to remind you. Okay, so that's about the introduction to the bounded counter problem. And make sure you understand the requirements. And then in the next video, we'll start developing some test cases using console applications.